Alright, this video is going to cover part 3 of circles. It's talking about arcs and angle relationships. The first thing we want to remember is the difference between an inscribed angle and a central angle. This picture gives you a good image showing ABD as a central angle and ACD as an inscribed angle. The inscribed angle's vertex is on the circle. The central angle's vertex is the center of the circle. Remember that an inscribed angle's measure is going to be half the central angle's measure. We talked about a central angle being congruent to its arc, and an inscribed angle is half the arc, therefore it's also half the central angle. That's that whole relationship between those three. So in this image, if ABD is 76, what is ACD? It will be half of that, which is 38 degrees. When you have two inscribed angles, here you can see the dotted line showing one and the solid showing another, intercepting the same arc, those angles are congruent. So since YZB intercepts arc YB, as does YAB, the angles are the same, which is half the arc. So if the arc is 102, each of these angles is 51. If you have an inscribed angle in a semicircle, that means it's intercepting a semicircle. So CE is the semicircle. Hopefully you remember that's 180 degrees. So when we take half, that's 90 degrees. So that is a right angle. Cyclic quadrilaterals are quadrilaterals inscribed in a circle. That means all four vertices are on the circle. So here you have I, H, K, and J all on this circle. When that happens, the opposite angles of the quadrilateral are supplementary. Hopefully you remember your vocab and you know that supplementary means they add to 180 degrees. So they're telling you these two are opposite, so they must add to 180. And these two are opposite, so they should add to 180. The measurements given here are not necessarily next to it, so read carefully. IJK, that's this angle here, is 95. KHI is this one up here, is 85. Do 85 and 95 total 180? Oh yes, they do. Okay, they tell you that JKH is 62 and that HIJ is 118. Do 118 and 62 total 180? Yes, they do. Another rule you need to know is when you have parallel lines intersecting a circle, the arcs between the parallel lines are congruent to each other. That means they will be the same measure in degrees. It does not, I repeat, does not mean arc ON is congruent to LM. That's a common mistake, and it's not true. That's why I underlined the word between. Now we're on to our angle relationships. The first one is if a tangent and secant chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So here you can see I've kind of written a formula for you. They tell you the measure of angle ABC is going to be half of arc AB, because that's the arc that's intercepted. So here we're given some numbers to work with. If you have RQ, the arc, as 118, what is the measure of angle QRP, which is on this side. So it's going to be a two-step process. More than one way to do it. I'll show you one way. 118 is the arc. The angle will be half of the arc. So we take half of the arc. So half of 118, or you can just say 118 divided by 2, same thing, is 59. So this angle is 59 degrees. And then you should realize tangent is a straight line, which means it's 180 degrees. So to get this angle QRP, you take 180 minus 59 and get 121. So this missing angle that they asked for is 121. Notice these are not drawn to scale. This definitely looks like it's acute, and they're telling us it's obtuse. So don't go based on the looks of your picture, go based on the markings and the rules. That's why it's so important to know the rules. Second angle relationship is if two secants or chords intersect in a circle, then the measure of the angles formed is half the sum of the measure of its intercepted arcs. Okay, again, you have an image with the equation kind of drawn out for you. This angle 1, it intercepts arc AD and CB, those two chords. Sum means to add. So I would add up the measures of the two arcs and take half, and that would give me the measure of angle 1. Hopefully you remember vertical angles are congruent, so notice 1 and E here would be the same measure. And again, you could find these two, because if you have a straight line, these would be supplementary. So really you can find all four angles created using this rule. This image tells us that XW is 61 degrees and arc YZ is 123, and we're asked to find angle ZUY, that is right here. So the arcs that intercepts are 123 and 61. I am to find the sum and take half. So half of 123 plus 61 is 92. So that angle is 92 degrees. Last angle relationship happens if two segments intersect outside a circle. Then the measure of the angles formed is half the difference. Sum meant to add. Hopefully you remember difference means to subtract. So here the angles outside the circle, the arcs intercepted are KM and JN. I subtract the larger one first and take half. So here in the image with the numbers, I'm looking for angle CAD. The arcs are 132. I subtract to get the difference, and then I take half of that. So half of 100 minus 32 is 34 degrees. Now we're just going to try a few examples using all of these properties. This first one, again, a couple of ways to go about it. I'm just going to show you one possibility. If the inscribed angle is 44, that means the arc is 88. You have to remember your chord properties that say two congruent chords, that's what those tick marks mean, is congruent, create two congruent arcs. So if a full circle is 360 and the arc AD uses up 88 of those degrees, that leaves us with 272. And then you have to divide it evenly between the two remaining arcs. And when you do that, you get 136. In the second example, you're looking for angle A, and we know that it's an inscribed angle, so it's going to be half of its arc, but we don't know its arc. So we're going to have to do a little work to find the arc, and then we can take half of that. Here this inscribed angle is 61, so its arc will be twice that, which would be 122. All of the other arcs are given, so I can total what has been used, which gives me 327. Full circle is 360. That leaves me with 33 degrees for this arc. Do not tell me your answer is 33 degrees because that's not what the question asked. The question asked for the angle. So you still have to take half of that. So divide it by 2, 16.5 degrees. All right, these two are using the angle relationship properties we just covered. The first one is an intersection in a circle. Okay, so since this one is in, we do the sum. Half of the sum of the two arcs, that's 70 and 52. 70 plus 52 is 122. Divided by 2 is 61 degrees. This angle is outside the circle, so we use half of the difference. We're subtracting. The larger arc is 140. The smaller arc is 74. 140 minus 74 is 66. Divided by 2, 33 degrees for this missing angle. This one is a cyclic quadrilateral. If you remember, we said they had opposite angles supplementary. So supplementary means they must add to 180. 180 minus the 120 leaves you with 60 for angle CDE. These angles must be supplementary. This box means 90. It's a right angle. 180 minus 90 is also 90. So this is also a right angle. Last but not least, we have parallel lines intersecting a circle. The arcs between are congruent, so I can write 28 here as well. I'm asked for DFA. DFA is a major arc. I'm going to have to add all of the pieces, but I don't know CB. I need to find it first. Do not tell me it's 113. These are not congruent. Only the ones between are congruent. So I'm going to add what I've used, which is 28, 28, and 113, which gives me 169. Take that from the full circle, and that's CB. So C to B is 191. So to get this entire arc, DFA, it's 28, 191, and 28. So I'm going to add my two 28s to this for a grand total of 247 degrees.